Okay, so today we want to take a look at another application of Pascal's triangle, just to see how this might tie into some other algebraic ideas. So recall back from algebra and algebra 2, right, that a binomial is just a polynomial that has two terms, right? So if it has two terms, then we call it a binomial. And when I say terms, remember that means that they're added or subtracted from each other. So that's what makes them terms. So for example, then, if I wanted to expand a binomial, right? Let's say I had the binomial a plus b, and I was raising it to the 0 power. Then obviously anything to the 0 power is just going to be 1, right? And if I were to raise a plus b to the first, then that would be just a plus b. But let me also put in here that not only will it be just a plus b, but that it will also be 1a plus 1b, right? And I'm going to change that to a red as well, and you'll see why. All right, so if I want to square a plus b, right, this is the classic. When we square this thing, it does not mean that it is just a squared plus b squared, right? We don't just distribute the square. So instead, we know that this actually means a plus b times a plus b. So when we multiply that out, we get a squared plus 2ab's plus b squared, right? So coming over here then, we'd have an a squared, 2ab. So we have 1a squared, a 2ab, and then a b squared. Okay, so what if I want to cube it? Right? So I certainly, if I, the long way here would be say, okay, well, if a plus b squared was this, then a plus b cubed would mean a plus b times a plus b times a plus b, right? But we already know what a plus b times a plus b was. That was a squared plus 2ab plus b squared. So then I'm going to multiply that by ab. So a squared times a is a cubed. A squared times b is a squared b. And then I would have 2ab times a is 2a squared b. And then 2ab times b is 2ab squared. And then b squared times a is b squared a. And then b squared times b is b cubed. And we can already see how this is a bit of a pain. But notice that we have one a cubed. We have an a squared b, and then two more of them. So altogether we have 3 a squared b's. And then we have 2ab squared and another ab squared. So altogether we have 3 ab squareds. And then we have a b cubed, right? And we have one of those. Okay. So let's see if we notice any patterns here, because obviously if I wanted to then find a plus b to the fourth, that would mean I'd have to take that big string and multiply it by a plus b, and that's going to start to get even more complicated. So hopefully we can find a pattern and a shortcut. So first off, if you look at the powers of a, right? So if I come up here and I look at the powers of a, then you can see that, right, in the first one, it was a to the first, and then the a was gone, right? So let's look at one that's a little more interesting. When I was squaring, right, a was squared, because I was squaring, and then it dropped to a power a to the first in the next term, and then the a was gone. Right? When I cubed it, it started out cubed, then it was squared, then it was to the first, and then it was gone. Okay. Meanwhile, take a look at the b's. Right? So just looking at the cubic, right, there is no b. In comes b to the first, then b is squared, then b is cubed. Right? So what do we notice about the successive powers of a? Right? They start with the power of the binomial and descend by 1 in each term. Right? Meanwhile, the b, right, the b is not there. Right? So in the first term, it does not appear. And then it ascends for each, ascends by 1, let's say, ascends by 1 in each term. Okay. And then you'll take a look there at the good old coefficients of each term. And look what you see. That's why I put them in a different color to hopefully help you see the pattern. Right? You've got a 1. Then in the next row, you've got, or the next power, you've got 1, 1. Then you've got 1, 2, 1. Then you've got 1, 3, 3, 1. And by golly, right, you've got good old Pascal's triangle. So the coefficients in the expansion actually come from the triangle. So it says, can you raise a plus b to the fourth without actually multiplying it out? And so the goal here would be, well, let's just look at this pattern, right? And so a lot of times what I do is I deal with the letters first and then just leave room for the coefficients. So the first term is going to be a to the fourth, right? Then the a goes down a power, so it would be cubed. And the b was not in the first term, so now it comes in. Then in the next term, the a drops to a square. The b goes up to a square. Then the a drops to a to the first. The b goes up a power. And then the last one, the a disappears, and b is to the fourth. So looking at the powers, right? The a starts out to the fourth because we're raising the whole thing to the fourth. Then it drops to cube, squared, a to the first, gone. Meanwhile, there is no b. Then it's b to the first, b squared, b cubed, b to the fourth. And then, to get the coefficients, we just think about what the next row of Pascal's triangle would be. Right? So if, move that up a hair, right? If I want the fourth row, it's going to be 1. 1 plus 3 is 4. 3 plus 3 is 6. 3 plus 1 is 4. And then the 1. And so there's the coefficients. 1, 4, 6, 4, 1. Now, obviously, you don't have to write the 1s on the a to the fourth and the b to the fourth, but if it helps you see the pattern, there it is. And so we raised a plus b to the fourth very quickly without ever actually having to multiply it out. And so we can do the exact same thing, right? If I'm raising it, say, a plus b to the seventh, right? I can do the exact same thing, okay? Now, the powers are a piece of cake then, right? So let's just do those. So we've got, it's going to start a to the seventh because I'm raising it to the seventh, right? And then the next term is going to be a to the sixth. In comes the b. Then it'll be a to the fifth. B is squared. Right? Then it'll be a to the fourth. B is cubed. So a is dropping. B is going up in power, right? So a cubed, b to the fourth. A squared, b to the fifth, a to the first, b to the sixth, and finally then b to the seventh. Now, the problem here is I now need the seventh row of Pascal's triangle, right? So, I could sit here and expand down to the seventh row, right? We could expand down if we wanted, right? Or we could look up Pascal's triangle if we, wanted to. But another way to do it is actually using your calculator or your Desmos, believe it or not. So the instructions here are actually for the old TI Inspire. What you could do is go into the function and then choose the combinations NCR and then do 7 comma X and then pull up a table, and then it'll let X be 0, 1, 2, 3, 4, 5, 6, 7 and show them all to you. But I actually, since I know most of us aren't using the Inspire right now, I wanted to show you how you can actually do this on Desmos as well. So if you pull up Desmos, and you can do it on the graphing calculator. We really don't care about the graph, but it's easier to type in here. All right, so you go to the graphing calculator, and if you press on functions, right, and then you can choose between trig and the different things here. So we actually want to look at statistics. So again, you're going to click over here on functions, go to statistics, and there's NCR, okay? And then we want the 7th row, so we're going to do 7, comma, but then instead of typing in the number 7, comma 0 or 1, 2, 3, we're actually going to just type the letter A. And when we do that, we create a slider. Okay, and so when we create a slider in Desmos, then we can actually come in here and let A be different values. And so all we have to do is slide our finger and we can see what it does. Now, the only thing is obviously when you're sliding it there, you're getting decimals and stuff, and that doesn't make sense. So what we can do is click on what A is. So you just click there on A, and you can say, well, I just want A to go from 0 to 7. Because it could be 7, choose 0, all the way up to 7, choose 7. And I want to do it one step at a time. And so now, when I grab that slider, so 7, choose 0 is 1. Right? It shows me that up there. If I slide it over to do 7, choose 1, it's 7. 7, choose 2, 21. 7, choose 3, 35. And then 7, choose 4, 35. 21, 7, 1. So that's actually a really nice little way. And the other cool thing is once you've done that, you know, if you needed a different one, you could just come in here and edit it and say, okay, now I'm going to do 7, or I'm going to do 10, choose A, right? Now you need to change your A to say I can now go up to 10, right? But again, now you can slide that and see all the different rows or all the values in the 10th row of Pascal's triangle. So coming back then to notability, right? The 7th row of Pascal's triangle was 1, 7, 21, 35, 35, 21, 7, 1. And there is A plus B to the 7th very quickly. Just imagine how long that would have taken to expand, right? And so we've got it just like that. Okay? So kind of another cool use of Pascal's triangle. So let's just take a look at a couple more examples of this. Okay? So I wanted to do a couple of examples where instead of just having two simple variables, A plus B, what if we had subtraction? And what if instead of one of them being a variable, what if it's a number? Right? So let's look here at how would you expand t minus 3 to the 5th. Okay? So, just like before, we look and say, okay, it's to the 5th. So that means we're going to start with t raised to the 5th. Right? Then in the next term, t is going to drop to the 4th. Okay? And then one other thing to think about here is a lot of times people prefer to think of it as t plus a negative 3. Okay, and then I'll show you, though, in a second another way to deal with this. But a lot of times, at least for now, let's do that. So t drops to the 4th power, and then in comes that negative 3 to the 1st, right? So then the next term, t is going to drop to the cube. Now the negative 3 is going to be squared. Then the t is going to drop to the the 2nd power. And the negative 3 is going to go up a power, so it's now cubed. Right? And then t is going to drop to the 1st power. Negative 3 is going to go up to the 4th power. And finally, negative 3 is to the 5th power. Okay, so just like before, right? the t starts out to the fifth, and then it descends. So t to the fifth, t to the fourth, t cubed, t squared, t, and then the t is gone. Meanwhile, the -3 was not in the first term, came in the next one, and so on. Notice that I put the -3 in parentheses. That's going to be important in a second when we simplify. Then we need the fifth row as Pascal's triangle, right? So again, if we go into Desmos, right, we can come up here and say, oh, I want NCR. I want it to be 5, comma A, right? And so now I only want to look at A from 0 up to 5. Okay? And so when I do that, so it was 0, 5 choose 0 is 1, 5 choose 1 is 5, 5 choose 2 is 10, 5 choose 3 is 10, and then 5, and then 1, right? So just like that, we've got our coefficients. So our coefficients were 1, 5, 10, 10, 5, 1. Again, you can get the coefficients as you go. I just tend to find it easier to deal with the variable, like the expansion of the variables and the numbers ascending and descending, and then I throw the Pascal numbers in at the end. Really up to you. Okay. Now, the only thing this time is that we actually have a little bit of more work to do, and that is just because this time we had a number, and so we want to actually multiply some of these numbers out, right? So we're going to have 1t to the fifth, and then right here, this is all multiplication right here, right? This entire term, all those things are multiplying. So 5 times -3 would be -15 t to the fourth. And then when I multiply this next one, right, notice I put that -3 in parentheses because -3 is getting squared. So I'm actually then going to have 10 times 9 right there. So I'm going to have 90t cubed. Okay. Then on the next one, because the -3 is cubed, I'm going to have 10 times a -27. Right? So then I'm going to get minus 10 times -27, so minus 270 t squared. -3 to the fourth is anyone, 81. So I've got 5 times 81t. Okay, so that's going to be positive, right? And then what, 405? So 405t, right? And then last but not least is the -3 to the fifth. So that's going to come out -243. So when I'm all done expanding this, one thing to note is because this time there were numbers involved, right? When you're done, you don't see the Pascal numbers out in front, right? Because they got multiplied by the other numbers within each term. So when you're finished this time, you don't see those Pascal numbers, but they were there when you helped generate your answer. The other thing I want to point out here is that notice it went negative, positive, negative, positive, negative. That is because in this problem, it was a subtraction problem at the beginning. If you're subtracting, it is always going to alternate signs. And the reason for that is because, right, the number's going to start out to an odd power, then it'll go even. Then the negative will be to an odd, then to an even, and vice versa. So as that descends, you're going to get negative, positive, negative, positive, negative, and so on. Okay? So you can either include the negative in there when you're doing the squaring and cubing, or some people prefer to say, well, as soon as I see it's a minus, I know it's just going to alternate. So as long as you remember to do that, totally fine. All right, last one. And this one's a little bit trickier because so you can see how they're building on each other. This time, when we think about the first part of the binomial, it's actually the entire thing 2x. Okay, so we're going to think of this as 2x as its own little term, and then we'll think of it as plus a negative y squared, right? And then all of that is going to the fourth, okay? So what you're going to do is expand this out just like normal. You're going to look at the 2x, and you're going to say, well, I know that 2x starts out to the fourth power. The hardest thing with that is remembering that the 2 is also going to go. So always put those little parentheses around it, okay? Then in the next term, that 2x is going to drop and be going to the third power, but in comes the negative y squared. Okay? In the next term, we've got the 2x that's squared. The negative y squared is squared. Right? And in the next term, the 2x goes to the first. The negative y squared is to the third. And last but not least, the 2x is gone. The negative y squared is to the fourth. We need the fourth row of Pascal's triangle, right, which we actually had up here. It was 1, 4, 6, 4, 1. So we can put those in. 1, 4, 6, 4, 1. So now we have technically applied the expansion. Now we again just need to do a little bit of simplifying. Again, putting the parentheses around the 2x, super important so that you remember then that the 2 is getting raised to the fourth as well in this case. So 2 raised to the fourth is going to be 16x to the fourth. Okay. Then in that next one, let's move that down just a little bit. In that next one, right, we've got a 4, we've got a 2 cubed, which is 8, and then we've got a negative 1, right? So because of that negative sign. So on that part right there, we're actually going to get a negative 32, and then x is cubed, and y is squared. Okay. Now the reason y is squared there is because, right, in the original problem, y was squared. Because now look what's going to happen in this next one here. So I'm going to have a 6. I've got 2 being squared. That's 4, right? I've got a negative squared. Right? This negative is getting squared up here. So that's going to become a positive 1. Right? But then I've got x squared, and then what's y squared squared? That's actually y to the fourth, right? So you can see where it's getting a little more complicated. So 6 times 4 then, 24, and then we've got x squared y to the fourth. All right, next term, we've got the 4, 2's to the first, so just a 2. The negative is getting cubed, so that is going to be a negative 1. So we're going to have negative 8x, and then here the y squared cubed is actually going to be y to the 3 times 2 is 6. And then on our last one, this negative is getting raised to the fourth power, so that is actually going to make it positive. And then the y, again, we multiply power to a power, so 2 times 4 is 8. And so there it is. And obviously you can see where, if you just saw that at the end, that Pascal pattern is lost. It's buried when you started simplifying things. But that is what it would be. Again, notice that it alternates minus, plus, because this was a subtraction. So I hope that makes some good sense to you, and you can practice some of this expansion. And then we're actually going to learn some more shortcuts with this in the next lesson. But for now, it's just learning how do I expand these things out, okay? All righty.